In this screencast, we're going to take a look at network programming in Android, and we're going to look at how to issue HTTP requests to a web service API in the network. We're going to look at how to parse the JSON string that we're going to get in response, and then we're going to look at how to properly put that network access into an async task. And then finally, we're going to look at how to create custom list view adapters. Alright, so I put together a simple program, the simplest program I possibly could, that incorporates all of the concepts that we've talked about so far this evening. So I've written this program called Top Tracks, and the idea is it goes off and it finds, using LastFM APIs, what are the top tracks listened to in various metro areas around the United States. So they publish all this information through their web service API, and my application simply lets the user pick what metro area they're interested in, and then it will go off to the network, retrieve that information, and display it, let them scroll through it, click on it, drill down, etc. So here's my application. I've got my emulator running here, and it's called Top Tracks. Gave it a nice shiny icon. So I'm going to go ahead and run it, and here's the default view. So right now it's just coming up. The list view is empty because I haven't gone off to the network yet, and so I can use the spinner here to pick what city I'm interested in and click the Top Tracks button, and it's going off, and you notice it popped up a modal dialog while it was doing that network transfer, and once it got the data, it renders the list. Now, not everything, of course, is displayed. It's scrollable. I believe it's bringing 50 of the top tracks down. And so if I were to scroll down into my list here, it's basically loading up these individual items as they appear. So the interesting thing is it's not going to download those image icons until they're actually needed. Okay, so there's really two different types of network accesses here, and we'll look at the JSON in a moment to help you understand that. But there's kind of the main JSON document that tells me the whole list with all the textual data in it, and then every item in there references various images, different size images and so forth. And so I get the entire JSON document on my initial fetch, and then after that I have to individually fetch the images. And this is going to be fairly common in a lot of the APIs that you might want to use. So we'll look at the content first, and then we'll go and start looking at the code. A couple other things I can show you. If I click on one of these, if I go to the artist button, for example, it actually uses the view intent with the URL I got out of the API and pops that artist view on the actual LastFM website. So that was artist, and if I back up, I'm right back into the exact activity again. But if I click on the actual item, it pulls up that songs page. Okay, and there's actually a preview button here. And notice the browser's using another intent here. Okay, and if I were to switch cities here, Okay, you get different sets of music depending on where you are. Okay, so that's the application. And before we go into the code, let's just take a quick peek at what the actual data looks like that we're working with. So this is the actual URL up here in my browser, and the metro variable here on my query string, in this case I've got it set to Denver. Okay, so if I change this to Seattle and do a refresh, it's going to pull the Seattle data. And the body of the HTTP response here is simply this textual data. Okay, this is just JSON, right? It's quite a bit of it, but it's JSON. So one of the things when you're working with these APIs that you might want to do, this is awful hard to look at and figure out how you're going to parse it. So what I do is there's a bunch of these online JSON formatters. So here's one, for example, jasonformat.com, and I'll just go in there. Oops, I didn't copy it. So I'll copy it from this, and I'll come along here, and I'll just paste it, and then I process it. And if it's valid down here, it does a nice, pretty formatting of it. And this formatting really helps me see the structure of that JSON so I can actually write the parse code for it. So that's a little trick you probably want to remember when you start working with these APIs and they return these great big huge JSON documents, and they're obviously going to get rid of all the white space in those things, all the tabs and spaces, because they want it to be nice and compact. But when you want to pull it apart and try to figure out how to parse it, you want to see it kind of in a view like this. Okay, so you can run it, and there's more than one of these out there. You can kind of pick and play with them and pick the one you like. And so if we look at the actual data here, oops, sorry. You'll notice it's returning an object, right? A JSON object. It starts with an open curly. And I've got a single attribute on that first one called top tracks. And then there's some metadata about the actual response itself. It's saying you're on page 1. We're putting 50 per page. There's a total of 500. So there's 10 pages. So I could do 10 more accesses here, passing it the proper parameters. And I could chunk through all 10 pages if I wanted to, but in my app I only care about the first 50, so I'm not going any further. Beyond that metadata, we actually have another attribute called track, and inside track you'll see is an array. See that open brace? And every element here in the array is going to have a ranking, an artist, a duration, an image. And for the image, there's different sizes, small, medium, large, and notice that's an array. So I happen to be pulling the medium out, and so I have to walk through that array until I find an object with an attribute size equal medium, and I know then that that's the URL I want to use to pull my image. And it's got other data, how many people listen to it, the actual name of it, whether or not it's streamable from LastFM, and then the URL to the actual song itself. And notice we also had a URL on the author, on the artist. Okay, so all these pieces of information that I need to populate my list view are all there in the JSON. I just have to understand the structure and write the appropriate code to parse that Java JSON string out. Okay? So let's look at the code. And I think what we'll do is we'll kind of proceed in the same order that we covered this material in the lecture this evening. So what I'll start with is let's take a look at where I actually go off to that LastFM web API. So we'll look at the actual HTTP fetch. Then from there we'll look at how we break that JSON string apart using the JSON processor that's available to us on Android. And then once we've seen how we do that, we'll look at how that's called from the async task And then once we understand, there's actually a couple of async tasks. Once we understand those, then we'll back up and we'll actually look at the custom view adapter that takes this data, the parsed data, and populates it in this custom into this scrollable list view. So in order to program with this API, I simply went to the LastFM website, and they had a link down there for developers. And if you go under the developer section of their website, you can sign up for a API key. And you have to, on this particular one, you have to use an API key. So every application that accesses it, they want to keep track of what application is doing what. And so you have to access with an API key. The APIs that you'll be using in the homework assignment this week, you don't have to have an API key. They're public. You can just call it without an app token and get the data. Okay, so depending on what web services you're using in your project this semester, you may or may not have to sign up for an account and get a API token. Many of them do require you to, and I've done so as well. When I distribute my sample code to you guys, I'll just leave my key in there, and you'll be able to run it, and that's just fine. But just keep in mind, if you're doing this in your own app, you'd want to generate your own API keys and have that associated with your name. All right, very good. So I've structured my program into some packages, and this is just the convention I use to make it easy for me to navigate my Android applications. And you can come up with your own conventions, but what I like to do is I like to put all my activities in one package. So in this particular application, believe it or not, there's only a single activity. That activity that puts the list view up with the button on it, that's it. And all the other activities that were happening there are just, it's the browser, it's stuff outside of my application that I'm just invoking through intents. Then I like to keep a package of all my adapters. So in this application, once again, I only have one adapter. If I had different views and multiple web APIs I was pulling from, it's, some applications you'll have a half a dozen adapters or more that you're using to format data, but this is a really simple example. So I've got a package for my adapters, and then a lot of times I will take my data that I'm pulling out of JSON and I'll represent them in POJOs, plain old Java objects, just simple objects with setter and getter methods on them. And so it's kind of like my model data if you're a model view controller, if you're familiar with that pattern. And so I'll put all my POJOs or my data representations in a package called data. And then I have all my tasks. These are the background things that I want to happen outside of the UI thread. So all my network access is going to happen through my tasks. And so I've got a couple of tasks that I've written in this application. One to actually grab the JSON document that describes the list of top tracks. And then I've got a separate task that fetches all the individual icons for me. Now, the other thing I like to do is I like to take all the API specific code and I like to push it out into a single helper class, okay? And then I refer to that helper class with more higher level stuff. So I can take all the integration code for one particular API and just put it all in one place. So in the future, that's nice because in the future, if I wanted to switch to a different provider, let's say I was doing venues, there's a whole bunch of places out there that serve up publicly data on venues. There's Foursquare and there's others. And so if I wanted, a month from now I decided some other web service gave me better data, I only got to change my helper class. Okay, I don't have, Foursquare or LastFM integration stuff spread across a bunch of classes. I got it all nice and isolated in one place. So that's what this helper class is that you see here. In this case, some of the structure I put in here is probably not necessary because the app is so simple. But I wanted to kind of show you, how I go about organizing my projects, my Java packages. And as your project grows, your project's going to be a lot bigger than this, the code that you're doing for your project. And so it's nice to have some some logic in how you're putting it together. You can choose to do it your own way, but this is simply the way I do it. So let's go ahead and take a look at that helper class. So this is my LastFM Helper. So this is the code that actually reaches out and uses the HTTP client to grab content from that LastFM API. And I've went in here and I've simply hard-coded as much of the URL that I need to access as possible. And of course, I've got to add at least one query string. I have to add that metro query string value because we're getting that one from that spinner that I'm putting up. But there's a whole bunch of other stuff on here. So the name of the method, and I found this all out by simply reading the LastFM API documentation. So you'll go off to Twitter this week and you'll be reading their documentation to try to figure out what kind of URL do you need to get the data that you want to appear in your application. So the last thing I have on there is my app token, and that's pretty much it. So when I'm ready to do the fetch, all I need to do is tack onto this thing my metro query string, metro equal Denver, Detroit, or whatever it's going to be. So let's take a look. I have a single static method here called download from server, and it takes an array of strings. That's what this syntax means here. And in this case, I'm only sending in a single string, but if I wanted to do multiple cities in one, I could. But in this case, I'm only using the very first one. So I'm going to pull metros out of param sub 0, and then I simply concatenate that to the actual URL constant that we just looked at a moment ago. So now my string URL here has the complete URL I need for the target data that I want to capture for the current button click. So this code should look familiar to you. This is the Apache HTTP client code. So I created my default client, I create my GET request, and then I go ahead and I execute the request on the client. I check my status, and if it's not okay, I'm going to throw an exception, which ultimately is going to pop a dialog up and say I had problems getting to the network, try again later. Assuming everything's sunny, I'm going to go in there, grab my entity, get my input stream off that, and then I'm just going to read it into this retval string on the bottom. So after this method is finished executing, it's got a string, a Java string that contains the JSON description of the top 50 tracks for whatever metro area I passed in as a parameter. Okay, very straightforward. So the interesting thing, of course, is how does this fit in? Where does it get called? Well, we already know from the road rules that we talked about, you're not going to be calling this method on your UI thread, okay, because it's going to take a non-trivial amount of time, and we don't want to block up that UI thread. And the other interesting question is, okay, now we got this data, how are we going to get the UI updated again with this data? And of course, we know the answer to that. This is where async class comes in. So let's take a look at our async task. I said async class. The async task class. So let's take a look at those. And I mentioned I have two. So let's take a look first at the main one, and that's called LastFM Web API Task, and it extends async task, and we've got the three types we talked about. So the very first one is going to be the input parameter. This is what you're going to send in to get the task initiated, and we know that I'm going to be searching for metro area, top tracks in metro areas. So this first parameter is going to be the string describing whatever metro area I'm interested in. The middle one here is the actual progress type. So as the background task is running, we have the opportunity to emit progress updates and have the UI reflect that. And the type I've chosen here is integer. I'm actually not using this. I'm not actually doing any kind of intermediate updates in the UI here, because I really don't know how long it's going to take, and it really doesn't take more than a couple seconds. You already saw that when I ran it. But in any case, that's what that middle type is for. And then the last type is the output I'm expecting to get back when this task is done. And what I'm expecting is a string, a JSON string from that web API for the particular metro area. So that's the how I'm driving from async task, and I'm passing into it the actual activity that was responsible for invoking this. So this activity is going to be my top track activity that displays this list of top tracks. And so this activity is what we're going to use to actually ultimately get that adapter, which we still have to look at, to reflect a fresh set of data that we've uploaded. So we'll use the activity to get at that. The first method that we overrid was the OnPreExecute. And remember, OnPreExecute is going to be called on the UI thread. So that means I can affect the UI here. I can call Android UI Toolkit methods and not have any problems because the right thread is calling it. So you're going to use OnPreExecute to do whatever you want to the UI to indicate that this task is going to start running. In this particular case, what I'm going to do is just pop up a modal dialog and put a message up there that says I'm trying to load top tracks for the given metro area. And that's exactly what this line of code does. It puts up a progress dialog, which is just kind of a spinny thing here, and it's got to have a context to do that, and that's my current activity. And there's a title, and then the actual prompt that I'm putting on that I've defined out in my string resources. It's just going to say I'm off looking for tracks for the city. And so when this thing executes, it's going to pop up one of these progress dialogues, and it's just going to sit there spinning with this text message on it to let the user know, hey, it's trying to load something right now. And then the next method that I override is the do in background. And notice it's passing in an array of my parameter types. In this case, I'm only going to use the first one, but I just passed those in. Remember, we looked at download from server, and it took an array as well. So I'm simply going to forward that on. And here I'm just calling my LastFM Helper .download from server, which we just looked at. So this guy here, the do in background, we know is going to be called from a worker thread. Remember, that's the way the async task works. So this method is not going to be called on the UI thread, so it's safe to do the network access at this point. And so that's precisely what do in background is for. So do in background gets called by a worker, and my UI thread is back happy processing its events, and now my dialog is up in the front here, and so off things go. And then ultimately that background task is going to finish. I'm going to get a string value back because that was that third type in my async class derivation. And so what I want to do now is I want to parse that string. So when we override OnPostExecute, remember this is something that is called on the UI thread. So we certainly don't want to take a real long time here. Okay, so if I certainly don't want to go off to the network again here, right? And I'm just making the assumption that I can process this, this file in maybe a few hundred milliseconds or something, and so it's not going to really block the UI. So the first thing I do is I dismiss the dialog. We're done. The fetch was completed, and so the first thing I want to do is get that dialog off the screen. So I dismiss it. The next thing I want to do is handle the special case of what happens if there was no top tracks, if the API, gave me nothing back. Well, I just want to tell the user then instead of just leaving it blank, they wouldn't really know if it happened or not. I'm just going to put a little dialog up there, a little alert that says, unable to find that data, try again later. Now, obviously, that string literal shouldn't be in my app. It should be up my resource file, but makes the code more readable. And so if I have that situation where there was no data, I'm just going to put up a dialog and get out of here. We're done. And otherwise, I'm going to have to take that JSON document and break it apart and read it. And so I'm not going to go through this line for line. You can go back and look at that data that the API generates if you want and confirm that I'm doing the right thing here, and it is. But basically, I'm going to walk through that list of tracks. I believe there's 50 of them in that. There's an array of 50 tracks in there, and every track is described as a JSON object, and it's got a name, it's got an artist associated with it. Both the artist and the track have their own URLs associated with them on the actual website for LastFM, and that's the data I use when you push the buttons or select the list item, and so forth. So you can, this is pretty straightforward. You can walk through this on your leisure and confirm that I'm doing the right thing. And what I'm doing is, when I'm done extracting the data of interest, I create this POJO here, a track data object, and that's just the metadata about a given track. And the track data instance here is simply an array list of them. So I'm creating all these little track data objects, and that's what ultimately is going to get sent over to my activity. So my activity defines a method called setTracks, which I wrote, and I'm simply going to pass it a reference to this array of data objects that I just downloaded from the network. And the individual data objects, let's just look at that class quickly, is here. And it's real simple. It's just a class that defines some variables, and then I got setters and getters for each one. So this is just a POJO, plain old Java object. So once it calls setTracks on the activity, we're expecting in this activity, we're expecting the UI to get updated here, aren't we? Because what we're essentially saying is we're off fetching some data, these tracks, these top tracks, and then now we're in the post-execute. So we're saying, hey, we've got a new set of data. We better get the list view to refresh itself. So if we follow this method call and look at it, we're going to see that it does. So I'm just going to go to the declaration here. You're going to see that it, first of all, it saves the track array as a variable on this activity object. Then we call a setAdapter method on a track list object, and we say give this thing a new adapter, and we pass, among other things, a reference to an image fetcher, a layout inflator in the actual track data. Okay, so before we go off and look at how we put together this custom adapter, I want to just spend a few minutes looking at the activity itself here, so we can kind of understand how that's put together. So the activity is just a straightforward activity, and it sets content view on layout main. And so let's take a look at what main has. So there you see main, and it's got our spinner, and it's got our button off to the right. So those are in a relative layout. And then underneath here, we have a list view. Okay, so we looked at list view when we talked about the list activity a couple weeks back, and it's the same thing here. So if we look at the XML, I've got a relative layout with a spinner in it and a button, and then underneath that, all of that's contained in a linear layout. I've got this list view. Notice this time I didn't give it the special ID because I'm actually not using list activity here. I'm just dealing with it directly myself. Okay, so that's another option you have. And so I can give it any name I want. So if we go back to our activity, the first thing I'm going to do here is grab references to my various views. So the interesting one, of course, is the track list. And that's going to be my list view object. And that's going to be associated with the track underscore list in my layout. And you can ignore this in manager. I actually had a text field up there initially, and I was using that to make the keyboard go away, and I changed it, so I should have removed that. So you can just ignore that for now. The next thing I do is I create a LastFM icon task. And it turns out that the first fetch that we just looked at grabs us the JSON, but embedded in that JSON for each one of, well, for most of them, there's an album image. Okay, some of them don't have it, some of them do. It depends on what metadata users have tagged those entries with on their web service. And so what I need to do is, as I render individual items, occasionally I'm going to have one that has an actual album cover that I have to download through some URL that I found in my JSON. And so once again, it's a network access, and I don't want to do that in the UI thread. And so when my list adapter gets called and says, hey, I need item X, if item X has a URL on it and I have not yet downloaded that image, I need to get that image fetch going. And so what we do is we've got this LastFM icon task in the background, and we can feed this guy URLs, and then it's going to quietly go off and fetch them, and it's going to create a cache, an in-memory cache. Now, this might not be a good way to do this if we wanted to really cache. Once my application exits here, all those images are going to be refetched. Okay, so I really want to store those images, or at least a subset of like the most recently used ones. I probably want to store them, right on the device in a database or on the file system, so that when the app runs the next day, if that same view loads up, it doesn't have to go back and refetch those. Okay, but we haven't talked about local storage yet, and I didn't want to complicate the code. So I just have an in-memory hash map where I'm actually keeping track of these. Obviously, that wouldn't be a good solution since there could be a lot of data in memory, and then secondly, once I exit my application, I still have to refetch everything again. But it's good enough for an example, just to show you how these pieces work. So and we'll look at the icon task here in a moment, but before we do that, let's finish the activity. The layout inflator is basically this mechanism that we're going to use. We can give a layout inflator a reference to a layout view in our resources directory, and it will actually give us back a view object reference. It'll go off and it will inflate. It'll go off and take that resource that we've described in XML and create the view group right in memory. Okay, so this is what happens on all your views. When you say set content view on r.layout.main at the top of this onCreate method, underneath, behind the scenes, a layout inflator is taking that layout main, it's inflating it into a view hierarchy that is basically being set here. Okay, so this was always happening before, it was just doing it for you. But you're going to need to use this layout inflator in your custom adapter whenever we have to create ourselves a new view for an individual item. We need to inflate it from a layout. So that's what that's for, and we'll see where it's used later on. Then I get my handle to the spinner, and I get my handle to the button, and I hang a event handler off the button. And again, you can ignore some of the code here. This hide soft input that was from some previous UI I had on here. But basically, this is what makes the soft keypad disappear. Maybe some of you want to know that anyways. So if you've got if you go into a text entry field and you don't have the keypad open, it'll pop up a soft keypad. And then if you want that to disappear, like when a button's clicked or something, you can actually hide it by calling this method on the input manager. So when you click on that button, okay, that button is what goes off and searches on whatever the Metro setting is. So what we do in the event handler here is we get the text from the spinner. So that's what these first two lines do. I'm sorry. The first thing we do is we create ourselves a web API a LastFM web API task. So this is the one we just looked at. We create a task that can go off and find all the top tracks for a certain locality. So the next thing I need to do is I need to go off and find out what is the current Metro setting. So what is that spinner set to? That's what these two lines do. Once I have that, I can execute the task with my Metro setting. Okay, so this is where we actually invoke it. It's happening on the event press. So when you press the button, that's when we create the task and execute it. Okay, now notice I said earlier that you have to create and execute your async task on the UI thread, but guess what? Where are we right now? We're on an onClick handler for the button, right? And so we are on the UI thread when this code is called. And this is what triggers that whole, it's going to pop the dialog up, then the background thread's going to start doing the fetch, and then the post execute, it's going to dismiss the dialog, parse the JSON, and then call back and make that adapter refresh itself. If I run into problems, I'm just going to call cancel on the task and tell the user, sorry, we didn't get any data. And that's pretty much it for my onCreate. So just grab some references, set view, grab some references, and then hook up that button handler that kicks off that main LastFM web API task. There's some more details in here. I'm just going to mention them briefly, and then you can research them more. But one of the things we can do here is when the orientation changes, remember Android creates a new activity when that happens. And so one of the things I want to do here is I don't want to go off and refresh all that data on the network. Just because somebody changes the orientation of the device, I don't want network traffic to happen. So what I do is whenever the orientation changes, a hook method gets called and we can actually save the current data so that when the activity comes around again in the onCreate, I go ahead and I say get last non-configuration instance, and if I get something back here, then I know that I actually saved the data, and I'm just going to repopulate my list view in the new activity with the saved data. And the hook method itself is right here. So when you override this, you basically can, whenever the orientation changes, you can save data, and then later in the onCreate, you can call this method, and if you get something non-null back, you can actually kind of store the data away so you don't have to refetch it from the network. Okay, so this is another way I can eliminate network accesses. Then I got my alert helper function that just does a make text, and the view holder we'll look at in a little while, and we already looked at set tracks. So let's take a look at the image fetching task, LastFM icon task. Okay, so this one here, the task is actually a nested class, and I mentioned that I'm caching my fetch to images in a hash map, so that's what this is right here. This is my image cache. And the constructor just creates a new empty one, and then I have a simple method here that's called load image, and I pass in the adapter in an image view, and the first thing I do is I go off and I say I've got every view tagged, and what I'm going to tag them with is the URL. So on all of these widgets you can set a tag, just an arbitrary piece of data, and then later you can use that data. So this tag basically helps me understand what is the image that this particular view image view is supposed to be showing. And so I'll look at the view's image and I'll say if I've got that URL in the cache, then I'm just going to grab that drawable and return it. If I don't have it, I now need to create a new image task and execute it and pass it the URL I want it to fetch. Okay? So if you've displayed the same icon more than once, it's only going to get fetched over the network once, and the next time it's going to come from my memory cache. And so this is where we're actually going to do this. And so the question is this called on the UI thread? Because we cannot create tasks and execute them unless we are on the UI thread. And when we get to our custom adapter code, you'll see that yes, indeed, we are actually calling this from the UI thread. Okay? But that's something me as a developer, I had to make sure that's the way this code was being called, and it is. And we'll see that in a moment. So as a nested class here, I've got the actual image task. And once again, it extends async task. And the first value is a string. So I'm going to pass in the URL of the image I want it to fetch. I'm not doing any kind of progress reporting here. And so I'm just setting the middle one to void. And then what I'm expecting as output here is a drawable. Something I can draw. So in this one, I'm not doing anything in terms of progress. I'm not doing any dialogues, and you need to think through when this task is being used. So by the time this task is being used, I've already got the list view populated with all the textual data. And what I'm doing is I'm trying to get the images filled in. So it turns out when we're rendering an individual item, if I don't have the image available in memory, I have a filler image that I use temporarily. Okay? I just put that filler image in there, and then I start the image fetch of the actual image, and a few seconds later when that real image comes in, we refresh the adapter and then it will display automatically. Okay? Now sometimes what people will do for that filler image is they'll put like an animated image there, so a little spinner image or something, so visually the user has a cue that okay, there's an image still coming in that particular view item. It's still coming, it's loading, and so for a few seconds you'll see those. And you've probably seen those in apps you've ran where the image, where an image is supposed to be, is just kind of a little spinning icon, and then eventually when it loads, it pops in there. So that's a technique you can use. In this particular case, I'm actually using the Java API, so I'm doing the fetching a little bit different here, just to show you some variety. And so in the background, we go off and we fetch, and once we've got the data in, we can actually, from the IO string that it gives us, drawable has a static create from stream that returns me the actual drawable object. So this is kind of compact, kind of terse, but this is what basically creates that drawable object of the fetched image. And on OnPostExecute, I don't have a dialog to dismiss, but I do want to get my list view to now refresh itself with the new data. And so what I can do, I had a reference to the adapter. You'll remember we passed that into the constructor. And adapters have a method called notifiedDataSetChanged. And when I do that, I can actually force that adapter, the view that adapter is associated with, to be refreshed to reflect the new data that I've downloaded. So all I'm doing really in PostExecute here is I'm storing my image in the cache, and then I'm notifying the adapter that its data has changed so it can refresh. Okay, so those are my two async tasks. They're both used in slightly different contexts. One of them puts a modal dialog up in the front to show progress. The other one just quietly downloads images and then forces the adapter to refresh once it has a successful download. Does everybody see how we're doing that? Any questions? Okay, so the next thing we want to look at, so we've looked at the HTTP code. We've looked at a couple of different ways to do the HTTP fetch in the two different tasks. Then we've also looked at the JSON code. We've looked at the overall activity. The last piece of code that we haven't looked at yet is the actual custom adapter. So we noticed in the onCreate, we got ourselves a handle to the list view in the onCreate of our activity. We got ourselves the reference to the list view, but we didn't do anything else with it, did we? We just got the reference. And the only thing we did to it is we set an adapter on it if we happen to be coming into the onCreate because of an orientation change and we already had the data downloaded. But otherwise, we're not doing anything, and that is kind of what you might expect, because remember when we ran this thing initially, the list control was completely empty. It was blank. So we've got the list view, but nothing's happening. So we need to look at that set tracks method again to see how the actual list control gets data. So let's quickly look at that. So set tracks, we looked at that once already. Remember, this was called from the PostExecute method in the task that we looked at. And it calls set adapter on our list. Set adapter is how we tell the list where it's going to get its data from. In the activity list that we looked at a couple weeks ago, we were just setting that to a prefabricated array adapter, and we were giving that thing just an array of strings. Well, now we've got some more sophisticated data. We've got this set of tracks, and each track has a whole set of data itself, and we want this stuff to all get formatted in a nice way. So we have to feed it an adapter, and we're going to create our own custom adapter to do this. So let's look at that custom adapter. First thing to notice is that we're extending the base adapter. So base adapter is the base class of our custom adapter, as well as some of those prefabricated ones that Android provides for you. And I'm passing to the constructor, we saw that in the previous method, a reference to the actual activity that is going to contain that list view. We're sending it a reference to an icon task. And remember, that wasn't the actual async task. That was a higher level class that included in it a nested class that implements an async task. Okay, we just looked at that code. And then I'm passing in an inflator. Remember, the inflator was something I asked for. I said layout inflator dot from, and then I passed my current context to it. And then the last piece of data I send in is the actual track data, the data that I've downloaded from the web API. So that's my constructor. I store all that data, and now I have to override a bunch of methods on base adapter in order to make this work. The first one you need to worry about is you have to tell the list view how much data you got, how many elements are going to be in the list. And so in my case, I've got an array list of track data, and that is going to dictate what the individual items in my list are. And so I can simply call .size on my array list to tell it, this is how many tracks I'm going to put in this list. So nothing sophisticated there. All items are available or enabled. That's true. So I want to be able to click on any of these. And get item can be used if you actually wanted to query the adapter and get the actual data content back, we could return tracks.get and then put the position argument that we're getting here, arg0. Okay. Most of the time you don't really need to do this. Most implementations is going to be end up null, but that's what that method's for. Get item ID is if we had this thing backed by a database, we might actually return the item ID. Given a position, we might tell them what is the actual corresponding ID of the database record there. And then finally, the interesting one, as I mentioned earlier, is GetView. So when the list scrolls, or it's displayed initially, when a particular item in that list is revealed, is now in the viewable window of that scrollable view, the framework is going to call this GetView, and it expects us to return an object reference back to a view object that has inside it, it's going to be the root of a view group, that has inside it that individual item. Okay, so what we want to do is we want to paint up a layout where we got the image up in the upper left, then we've got in a bold face the name of the track, the artist in a slightly different font, then a button over to the far right with the label artist on it. Remember, that's what they looked like in our application. So when we're done with this method, that's the kind of view. Furthermore, the individual data that's bound to those controls has to reflect whatever the item data is for this particular position. So it passes us in several pieces of data. The first is the actual position. So we've got, in this case, we're going to have 1 through 50 of these. So position is going to be 0 through 49. The next thing is a potentially recyclable view. So this thing is scrolling all kinds of these, and when something goes off the screen, it's no longer visible. We should be able to reuse that. So the framework will let you recycle these view objects. Okay, and this is because we're on a resource-constrained device. We want to minimize memory allocation and deallocation, and so it's just giving us the opportunity to reuse. And so the very first thing I do, oh, and then the last thing is the view group parent. So that would be the reference to who is containing this item, which is going to be the list view. So the very first thing I do is I take a look at that convert view because that's my potentially recyclable view. If it's null, that means it doesn't have anything to recycle. I got to create something. In that case, what I need to do now is create myself a view hierarchy to represent this particular entry, and I need to create it from scratch. So previously when we did layouts, we always did a set view and onCreate, and it kind of took care of the details and resurrected this thing into memory and created all the Java objects. Now we've got to do that. So what we've done is we've written a layout that describes precisely the layout of one item. And what we can do is we can take that layout inflator, we can call inflate, and we can give it a reference to that resource, that layout resource, and some other parameters. And what it's basically going to do is it's going to create a brand new view for us that has all of those components that we described in our layout instantiated. So before we look at the code that follows, let's take a look at this layout track row that I created. So track row describes an individual row in my list control. Well, let's see if we can get this thing up in... Okay. So you'll see there's an image over here, text. There's text down underneath here too, but it's, I guess I didn't set the default value on it, so it's blank. And then there's a button over here. So if we look at the XML, it's a relative layout. Here's my image view, and that's my album icon, followed by a text view. This is going to be the track name, so that's going to be in the bold font on the top. The next text view, which falls right under it, is going to be my artist name. And then finally, over to the right is going to be my track button. That's the one that when I push it, it's going to go off and retrieve the data from the LastFM website. So this is simply a layout, just like any layout. And so we can take layout inflator and say inflate this layout, and now we've got a reference to a view object that is the container of this configuration right here. So going back to the code, oops, I was in the adapter. Once we've inflated it and we've got a view, now we can go in there and we can actually pull out references to those individual widgets that were defined within that, and we can go and use that data to set the actual values. So what I'm doing here is I'm creating my own little convenience class, and I called it my view holder. I just want to take all of these references to the inside controls and bundle them all up into a simple class. And so this view holder I've defined maybe it's below. Well, let's go like this. Oh, it's a nested class on my activity right here. So all it is, it's like a POJO, right? It's got my references to the track name and the artist name. That's the textual data. It's got a reference to the track button, the image that I'm going to display, and then I also kept a reference to the actual data that is going to be used to populate these. So this is just convenience I've used to bundle these all together in my adapter. And sure enough, you can see after I've created an instance of it, I go ahead and I populate its values with these actual view references. And the last thing I do is I set tag on my button, and I take that holder object and I put it right on the button. Okay, so it's just a reference, and I can tag buttons, I can tag any widget with anything I want. And so I'm taking all this information, this bundle of information, I'm tagging it on the button. And as you might suspect, when that button's pressed, I can do a get tag on the button view, and now I've got references to everything. I've got the URLs, I've got any of the data in that particular item. I'm going to have access to it, and I can act on it however I want. The actual view itself, so that's the row, I'm going to take the reference, I'm going to tag that view as well. You remember I had two different ways I could interact with an individual item. I could push the artist button, and that caused the artist page to pop, or I could select the item in the list, and that caused the track page to pop. Okay? So by setting the tags to this data, when those events happen, I get a reference to the view object in the event handler. So I can call get tag, and I can get all of these pieces of data back in that event handler to do whatever I need to do. Okay? For sure I need the URLs, so if I wanted to, I could have just tagged them with the URLs. That would have been sufficient. But in a lot of cases, you might have, edit, delete, you might have a lot of things, and you might need all the data. And so I took this approach just to show you how when you get into that event handler, if you take this approach, you can have all the data you need in that event handler. Okay? And you only get one tag, so if you want to send multiple pieces of data, you need to somehow bundle it together like I've done here and send it in there. So that was kind of the situation when GetView is called and it doesn't have a recyclable view. I got to go through this work. So the very first time this runs, and that initial 7 or 8 items show up, this is going to get bang, bang, bang. We're going to get called with a bunch of nulls. But as you start scrolling back and forth, we're going to start getting called convert view with non-null ones. Okay, so that I can recycle. Now it's much more efficient. If I've got a non-null, item, then I can simply say, hey, this converted view is from this list controller, so I know it's got tagged with a view holder. So if I pull that out, I automatically now can get handles to all these items, these controls that were set in the holder. So down here, I'm going to set a click listener, and I'm saying this, and one of the things I didn't point out is I extend base adapter, but I'm also implementing my click listener right here on my adapter. So if you click on an item in the list, I'm going to actually handle it right here. So I put that listener on the item itself, and I also set, I guess I do that later, on the button. So now I've gotten myself a view. I've got my holder set up with all the references to the actual controller elements. Now I need to take the actual data, track data, and set all those controls to reflect the data of interest. So I go ahead and I get the track of interest. So I was passed position as an input parameter. So this is, I'm looking at the ith entry in the list right now. So I fetch the data out of my array. I set all these values in holder. So I'm going to do set text on name, artist. I set my listener to this. So I'm going to end up in the same event handler for item clicks and for button clicks. And I'll show you in that event handler how I'm deciding which of the two happened. If there's an image URL on the track, not all of them have it, some will be null, but if there is one, I'm going to, on the icon, I'm going to tag it with the URL. Then I'm going to call my image fetcher and say, hey, load me up this image. And we just looked at that code a few minutes ago. This basically says, do I got the image in memory? If not, create myself an image fetch task, get that going in the background, and then later, when it fetches, it's going to update the adapter view automatically when the data changes. If I didn't get, or if I got something back, then I'm going to go ahead and set image on it. And otherwise, if there is no URL, then I'm going to set a filler icon on it. And that's just something I found and dropped into my folder. So it's just a little LastFM logo, a button that I put in there. So if I don't have an image, it's going to have the LastFM audio Scrabble icon on it. So the very last thing I'm going to do is just return that view back. So it's either a recycled view or it's a brand new fresh one. But in either case, I've now set all the data for the ith entry on that particular set of controls. Okay? This is really the key method when you override that base adapter. This is where the heavy lifting gets done. Okay, you're either going to, the strategy is recycle the views that are being passed to you. If you get a null pointer, you've got nothing to recycle, you better create one from scratch and populate it. The last thing to look at here is the onClick handler. So remember, we set the onClick listener and directed those events here. So the very first thing I can do is ask that view for its tag. And remember, in that view, both the item view as well as the button object, I've tagged it with the holder object. So the first thing I'm going to do is just pull the tag off it. Then I can ask the question. I can say, hey, the view that triggered this event, was it a button? So I'm saying, is V an instance of button? If it was, I know that that's the button that says show me the artist view. So in that case, I create an intent with action view, and I go ahead and I just grab the artist URL out of the track data and set that as the URI, and then just do a start activity. This is all stuff we've seen before. If it's not a button, then it's the only other option is it's got to be, the actual item in the list that was pressed. In that particular case, I'm going to show the track view. So then I pull the track URL out of the data and start activity on that. Okay. So by looking at the type of the view object presented to the view handler here, I can differentiate, was it my button or was it the actual item in the list? Okay. Any questions? Yeah.
Can you go back to where the image is loading? Just a little bit. So when you call the load image, and then it goes off and it does the background task and it loads it.
Yep.
It actually returns, it's going to swap out that filler icon with the real image. I think I missed that connection. Where does it actually do that?
Okay, so what it does is if we look at the actual image fetch task, okay, which is buried inside this image fetcher. So if we go, let's just go into the code here. Okay, so remember the LastFM icon task itself was not the async task. It was actually down here as a nested class. So this is the method we're calling from that GetView method that we were just looking at in the adapter. And so we're looking and we're just putting this layer of indirection here because it might be cached and then we don't need a task. So that's why I kind of structured it like this. So if it's cached, we're just going to return it immediately. If it's not, we're going to be, I think this is a null. Okay? And so it's going to come back as null, but one of the things I did in the actual layout was I defaulted it to that default filler image as well. So either it's going to get it from there, or if the URL simply doesn't exist because that item is not tagged with it, that's when we're going to follow in the branch and it's going to set the filler. But the interesting thing is if it's not there, that means it's got to get it off the network. Then we end up down here. We execute, we create a new image task and we execute it. That's what's defined down here. And your question was, once it's fetched, how does it get updated, right?
Yep.
And so if we look in the post-execute, we put it in the cache. So this is what happens after we finish the fetch. We now have a drawable from the fetched image, and then we say take the adapter and call notify dataset changed. That forces a refresh on the list that's associated with that adapter.